Hey, Mr. Harrodham here. We're going to go over some strong acid and base calculations. Okay, so to do these, you have to have your strong acids and strong bases memorized to know when you are using these method for calculating out the concentrations, the pHs, of acids and bases. See if I can straighten up my camera. No, probably not. Anyways, okay, remember that these dissociate 100%, okay? These will split into ions. Remember that these have a one directional arrow if it is a strong acid or strong arrow, Mr. Harrodham. You wrote away. If it's a strong acid or base, you have a one directional arrow for strong acids and bases. What do you do if it's weak? There's a different method that you'll eventually learn. We will be calculating out the molarity of the acid. We will need to find the pH and the pOH. pH and pOH are given. We're going to have to find out the molarity of the acid and base. We're going to have to use the molarity formula, which remember is mass over more mass over liters of solution sometimes here, right? Okay, so nitric acid here. This is an example here. Nitric acid. Okay, the first step you're going to have to do is write the dissociation reaction here. Remember that this is a strong acid. It dissociates into H plus and HNO3. Okay, then we will use a mole ratio. Mole ratio is the technique for see if I can spell that, for strong acids and bases. Okay. So since this is a 1-to-1 mole ratio here, we take our molarity, we do 1-to-1 mole ratio, and we end up with 0.033 molar H plus. Doesn't always happen, but it does for this one. Then you use the pH equations, the square, to find the pH. pH is equal to negative log of H plus, negative log of 0.033 molar, and we get a pH of 1.48. Okay. Sample number 2. Strontium hydroxide is a strong base. And I have calcium written in the notes. Awesome. Awesome. Okay. I'll fix that. Okay. I'm going to change this to calcium just for fun. Okay. Strong base. Okay. These are the bases that you have to watch out for. You have to watch out for your calcium hydroxides, your strontium hydroxides, and your barium hydroxides. Okay? Why am I telling you to watch out for those? Those are the ones with the 2-to-1 mole ratio. Okay? So for instance here, calcium hydroxide dissociates into calcium and hydroxide ions. Since this is a strong base, we're going to use a mole ratio to find the concentration of OH. So you take your original molarity, you multiply it by your mole ratio here, since there is 2 here, OHs, so you do wham, 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 2 OHs per 1 calcium hydroxide. You end up with 0.066 molar OH. Then you use the pH equations to find the pOH here. So this one, you're finding the pOH first with the negative log of OH, which is 1.18. Then once you get the pOH of 1.18, pH 14 minus 1.18, 12.82. Okay. I'm going to show you one problem right now here, and then, yeah. Okay, here we go. What is the pH of 0.050 per chloric acid solution. Okay, so this is a strong acid. Okay, the first step we're going to do is the dissociation reaction. So perchloric acid is HClO4 aqueous. That is going to dissociate into H plus and ClO4 minus. Aqueous, aqueous. Okay. The next thing we're going to do here is we're going to do the mole ratio to find H plus. Okay, so we know we have 0.050 molarity of HClO4. We are going to find the molarity of H plus. So we're going to put moles on the, we have molarity on the top, so we're going to put moles on the bottom, and then we're going to put moles on the top. That don't make sense. So we write down the substances here. HClO4, H plus. This is a 1-to-1 mole ratio. And we end up getting 0.050 molar H plus. And then finally, in the final step on this one here, okay, step 3, use pH equation. Since we are trying to find the pH. So we know pH is equal to the negative log of H plus. pH is equal to the negative log of 0.050. pH is equal to 2 sig figs, 1.3 for the solution. Okay? That is basically how we do a strong acid-base compilation. I'll be back with you next time to do other ones. You guys are champions. The legend is out. Oh no, I'm pressing the wrong buttons.